Thank you, Saqib. And there's multiple parties that are involved in this, that have been involved in this lagoon closure, that without their assistance and help and brainstorming and including Saqib's assistance, this project would not have been possible. As Saqib indicated, I've got a poultry lagoon closure that we've been working on in Texas for quite some time now. And the first slide that we've got is a photo of the facility with the full lagoons in the foreground, taken in the spring of 2006. And in the background, you can see 4 of the barns. Actually, I'll be talking on the next slide just a little bit. But this is about, what you're looking at is about the size of a football field of sludge surface area-wise. Okay. The background on this facility is that this was a caged egg laying operation with 6 houses. The lagoon size was initially unknown. It's 11 to 12 acre-feet of storage, or 14,800 cubic meters of storage. And it is actually one of the smaller lagoons in the area for this type of operation. The operation began in the late 1970s. The operator chose to shut down the facility in May of 2006. This was a demonstration project between both the NRCS and the Texas State Soil and Water Conservation Board, which is the counterpart agency to NRCS in Texas, and the local soil and water conservation districts. The purpose of the demonstration was to establish the cost for this practice, as we've got numerous of other lagoons similar to this across the state, address concerns in an impaired watershed, and prevent the manure and wastewater from going down if it were to overflow into the neighboring creek, and also properly close the facility to mitigate water quality impacts both to surface and groundwater. The entire site is approximately 11 acres. If you look to the right is the full lagoon area, is where the lagoons were originally constructed. That material was excavated from that area. It's at the very top of the hill for the area, and it was placed underneath these slabs that are labeled for demolition. So when they constructed this, they put all of the dirt that they removed from the lagoon and they used it under the slabs and sloped the slabs back to drain into the lagoon, which avoided any outside drainage from coming into this facility. The natural grade is shown of what the original site looked like with the green arrows, and the average slope across the site is about 0.2%. Since there is no area for wastewater application, the assumption is that this was based on a total evaporation system. The water was removed from the lagoon and then pumped back up and used to flush the slab. So the only freshwater input into the system was from overflow from drinking nozzles on the site. Okay. Then on the next, we've got the contracting. The initial thought was to go out and have one bid, after all the engineering work was done, have one bid for removing the sludge, hauling it off-site, finding a land application site, taking the soil samples for the land application site, spreading it according to a nutrient management plan, and then the final earthwork and grading, and to do it all in one with one contractor in one short time period. However, we received the bids for that, and they started at $1.8 million and went up to $3 million. We did not have that much funding available for this project, so we ended up going back and starting over to some extent to split those contracts up. The cost so far for the project, we've completed phases 1, 2, and 3 of the split up contract. In the first stage, we spent around $60,000 for removing the sludge and water. We did not pay for the sludge hauling and application, but that cost was about $90,000. That was paid for by a third party. There was a landowner that wanted this material, and he was willing to pay for someone to haul it and truck it onto his site, which compared to other fertilizer costs and some of the benefits he reaped, it made it worth his time and money to do that. Then the final site work for the final grading was around $90,000. So to date, we've spent between NRCS and the State Soil and Water Conservation Board approximately $150,000. In addition to the actual contracting cost, there are some additional costs. And these are shown on the next slide. We have a significant amount of time that was spent on engineering, surveying, creating drawings in both Civil 3D and Eagle Point, specifications, design report, also closure plan development, some contracting time and expenses, meetings, coordination, other communication time within agency, within other parties, other agencies, also lab analysis that were not included, that those were done through other programs, and then moving the power lines, final establishment of vegetation, and one additional cost that's not shown is the landowner will have to file deed recordation. Okay, now moving back from the actual cost side of this project, the methodology for this project was we conducted a survey of the existing site. We took soil samples to determine the in-situ materials and construction specifications. On the next slide, we've got a photo of us actually out collecting some samples for the initial sampling. This was in the spring of 2006. And we gathered those samples and sent them off to A&M, or took them to A&M for evaluation. Here's some of the sludge analysis. Typically, we're looking at about 4.4% phosphorus on a dry basis, and or 200 pounds per dry ton. And this was pretty wet material, average around 33%. Socket was able to, between him and one of his grad students, they were able to perform the sludge analysis for us, and there were 8 samples taken. Ironically, the sludge resembled dirt, and it had almost no odor associated with it. Additionally, the next slide shows the wastewater analysis from a couple of samples that were collected. And if you notice, on the phosphorus, we're now reporting in parts per million rather than in percent. So we had a very small amount of phosphorus in the wastewater compared to what was in the actual sludge. Okay. One of the challenges that we had on this site was knowing what we were dealing with, because from the first picture, you could see it looked like one single lagoon. However, when we got back to the field office and we started digging through some old aerial photos, we found this one. And it's clearly evident that there is 3 lagoons. A local field technician was able to deduce that that big, large lagoon that's on the upper end of the screen was for the original 4 barns that were built on the facility, and then an additional 2 were added later in the early, about 5 years after the facility started. And then that little narrow thing along the end, they had actually water that had come over from neighboring area into it, and so they dug out, excavated some more to build up a berm around the outside of the lagoons and protect it. On the next slide, we've got a photo of the aerial from the 1960s, so that gave us a pretty good idea of what we were looking at for the facility. Then on the next slide, our local technician was able to track down the original contractor, water hookups, and other information. Leslie, if you could change the slide. And we were able to make a lot of confirmations. However, even with having found the original contractor from the 1970s, he did not recall the actual dimensions or details of the construction of this lagoon. He remembered building it, but that was about it. Next slide. We took some soil samples at the site to determine if the material was the same as what was indicated on the soils map and what the local technician knew was in the general area. Just because our soil sampling depth typically only goes to 84 inches, so we needed to go farther down than that for this lagoon. And the sampling indicated that the soils were acceptable for in-situ mining material, and we did not find any indication of seepage from the lagoon. In order to establish the boundaries of the lagoons under the sludge and wastewater, we tried several methods until we came up with one that worked. The sludge judge, which is a long tube, and you put it down, and you're supposed to twist the little thing, and it taps off the end, and you pull it out. Well, that did not work. It ended up clogging, and nothing actually went up on the inside of the tube. So we tried pacing and using a range pole, but we didn't have adequate horizontal or vertical control. And then finally, we ended up using a survey-grade GPS unit. We took a surface shot and used a range pole to probe, determine the depth of sludge and wastewater. We collected about 200 to 300 points using that methodology across the surface of that lagoon. Another item to consider on the next slide is, besides being concerned with below-ground utilities for excavation, we have to watch out for above-ground power lines. In this case, the contractor had to obtain permission from the utility company in order to work under the lines, and we also had to make sure that we address this in the plans and specifications. After all of the surveying work was completed, there were approximately 2,000 data points that were used to model Eagle Point at the time, the various levels of sludge, wastewater, and then develop a final grading plan and associated quantities. Additionally, we developed a draft closure plan prior to any work for TCEQ review and approval, and the final closure plan will be completed after the vegetation is established on site. We also developed a design report, engineering drawings, construction specifications, and as one of the handouts is a sample construction specification that covers all of the phases for the entire project from start to finish. The construction specifications address typical items that you would see in most of the construction projects for NRCS. Additionally, there were some specific construction specifications written on the next slide for the removal of litter, sludge, and wastewater, the structure removal, earth fill and excavation, seeding and mulching, and then final construction survey, and the ability for the contractor to question any of the quantities that we had in the drawings or the specs. So for phase one, we broke it down and we included only the removal and stockpiling of the sludge and windrows on site. And if you remember, since everything drained back to the lagoon, we were able to stockpile on site without any fear that we were going to have a discharge running off site. We awarded the bid, and as soon as we awarded the bid, it rained. And the site received about 5 to 6 inches of rain. The contractor, the way that the bid was written, he was responsible for removing that water. However, we added an additional stipulation that if there was future rain after this, that he would be paid $10 per 1,000 gallons. And we addressed this a little bit differently when we got to phase 3 of bidding. Next slide, please. This is some photos of dewatering the lagoon in phase 1. And then on the next slide, we've got some of the different types of equipment that were used. It looked basically like a rock crushing facility. If anyone's ever been to a rock crushing facility, you've got a hopper and conveyors and front end loaders and a track hoe, long reach track hoe. One of the items that was learned is shown on the next slide. It started out, as you can see on the left photo, with a stationary hopper, and that caused major headaches for the contractor. Every about 5 loads, he had to stop the conveyor and have someone go in, shut down the operation, and scrape down the sides of that hopper because the material was clinging and caking to it. It resembled a clay soil. So they went to a vibrating hopper as shown on the right. This is what the final looked like after they were done. The top 2 are the sludge excavated, and even though moisture content was still below 50%, it still kind of slept off and ran everywhere to some extent, but it stayed within the boundaries that were identified. And then there's a photo of the bottom empty lagoon. As we were stockpiling as the manure is being stockpiled on site, samples were taken, and this is the result of at least 20 different samples, and there's one every about 1,000 cubic yards. And the phosphorus here is showing up about 5.7%, which is higher than what we originally had from that first laboratory analysis. For phase 2, the local offices were able to find a landowner that wanted the material and was willing to pay for the transportation and spreading of the material. There was a significant amount of time spent finding this landowner, as the local applicators in the area were accustomed to poultry litter but did not have proper equipment for hauling sludge. So this hauler actually came in from the Texas Panhandle, several hundred miles down to the site. The next slide shows the completed site and part of the bid showing for the next phase. They did an excellent job of removing all of the sludge from the site, and finally, basically, we had slabs to be removed and final grading work. So on phase 3, we went to final grading and vegetation and establishment. However, when we went to go to bid this summer, this area had not received hardly any rainfall all year. There was no soil moisture, and trying to spend money to have 20 days of irrigation following seeding and water really was not available in the area. Seemed like that was not a good choice. And additionally, the site only has a 0.2% slope. So instead of going ahead with the seeding and vegetation, they graded it and put silt fence in place. Also, one of the challenges that we had on the next slide is the power poles. Initially, there was an agreement 3 years ago that the power company would charge somewhere around $300 to move the meter box, and then they weren't going to charge for the moving of the power poles. However, this area has witnessed some extreme oil and gas activity, and so they wanted to charge 3 to 4 times the original quote to do anything. However, the local technician was able to negotiate that we got the cost down for that to the original price from 3 years ago. And the reason for moving those power poles is to avoid having a little island around each pole because we were making cuts along both sides to fill the lagoon. The next slide shows the final site after grading and a close-up of the silt fence. And then finally, right now, we are currently in phase 4. The site received some rain a couple of weeks ago. So we actually have someone that's supposed to be on site in the next, either today or in the next 2 or 3 days to vegetate the site. And once that's established, we'll complete the final closure plan and have the landowner deed record to make sure that any future landowners do not come up to the site and say, oh, this is kind of the top of the hill and it would be a great place for a house or other structure, because that fill material was not compacted to the level that would be needed for structural support. And we did not design that for that. Anyway, thank you so much for your time, and I will turn it back over to Sakib at this point.
Thank you, Catherine. We have heard about